Hello and welcome. I am Dr. Pauline Fu. In this lecture, I will present basic statistics concepts and techniques by going over some exercise. So, this exercise is about qualitative data versus quantitative data. Question 1.1. Colleges and universities are requiring increasing amount of information about applicants before making acceptance and financial aid decisions. Classify each of the following types of data required on a college application as a qualitative or quantitative. So the first one, high school GPA. High school GPA usually is expressed by numeric values, for example, 4, 4.5, 3.7. So this is a quantitative data. Quantitative data. B, country of citizenship. Country of citizenship may be US, Canada, China, India, etc. So those are the names. Okay, it is qualitative data. C, applicant score on the SAT or ACT. So this is the marks, maybe 78, 65, etc. So it is a numeric value, quantitative data. Gender of applicant. It is maybe male, female, LCBG, etc. So it is a category of people's gender. It is qualitative data. Parents' income, usually in dollar values. It is a number, numeric numbers. So it is a qualitative data or quantitative data. Age of applicant. It is a number, numeric number. So it is a quantitative data. Okay. So this is this exercise. Now next one, question 1.3. 1.3. You can read over the description here. So the question asks you, identify each variable measured. Okay, so you have a model name, manufacturer, transmission type, engine size, number of cylinders, etc. So on each type of data, do they belong to quantitative or qualitative data? So the first three columns are qualitative data. The first three columns is qualitative data. Okay. So after from this column, engine size, number of cylinders, until estimate highway mileage, those are numeric values. So they belong to quantitative data. Okay. So that is session 1, qualitative data versus quantitative data. Okay. Session 2 is about population samples, random sample. Okay. I'm going to do some questions, some exercise. Okay, it is a textbook on page. Try to find the page number here. Okay, page 7. Let's look at 1.8. Try to 1.8. Jamming attacks on wireless networks. Terrorists often use wireless networks to communicate. To disrupt these communications, the U.S. military uses jamming attacks on the wireless networks. The International Journal of Production Economics described a study of 80 such jamming attacks. The configuration of the wireless network attacked was determined in each case. Configuration consists of network type and number of channels. A. Suppose the 80 jamming attacks represent all jamming attacks by the U.S. military over the past several years, and these attacks are the only attacks of interest to the researchers. Do the data associated with these 80 attacks represent population or a sample? Okay, population or a sample. So the definition of population, all people or object. Under the study, the definition of sample, part of people or object. So here it is say represent all, the keyword ALL. So those 80 gems should belong to population. The population is 80 gems. Okay. B, 80 jamming attacks actually represent a sample, describe the population for which this sample is representatives. Okay. So suppose 80 is just a sample. So what is the population? The population is all jamming attacks across the US. Maybe there are 2,000, 5,000. So all jamming attacks are populations. This 80 is just a sample. Okay. So this is this one. Next question. 1.10 Gallup Youth Poll. A Gallup Youth Poll was conducted to determine the topics that teenagers most want to discuss with parents. The findings show that 46% would like more discussion about the family financial situation. 37% would like to talk about school, and 30% would like to talk about religion. The survey was based on a national sampling of 505 teenagers. Select a random from all U.S. teenagers. Question A, describe the sample. Okay, describe the sample. In this study, what is the sample? The sample is 505 teenagers. Okay, that is the sample. 2, describe the population from which the sample was selected. The population is all teenagers across United States. All teenagers. Okay. This is a question C, B. Okay. Question C, is the sample representative of a population? Okay. And you have to see how the sample is selected. Okay. So the description said the sample is selected at random. If the sample is randomly selected, it is the representation of population. So the answer is yes, it is representation of the population. And so question D, what is the variable of interest? What is the variable of interest? Okay. The variable of interest is the topics. So this research want to see what kind of topics teenagers most want to discuss with their parents. Okay, so this is the variable of interest. E, how is the influence expressed? Okay, how is influence expressed? So you might want to say based on the sample of 505 teenagers randomly selected from the United States, we can say that 46% would like discussion about family financial situation, 37% would like to talk about school, and 30% would like to talk about religion. Question F, newspaper accounts of most polls usually give a margin of error, for example, plus or minus 3% for the survey result. What is the purpose of margin of error, and what is its interpretation? The purpose of margin of error is to give a range of the data. So instead of saying 46% would like to discuss about family financial situation, I would say maybe from 43% to 49%. Okay, 43% to 49% would like to talk about financial situation. Okay. So that is this question, population sample and random sample. Okay. Next section, section 1.3 is describing qualitative data. Qualitative data. Okay. So I'm going to go to the question from that section, which is on page 11. For this one, you can, I will try to copy, if I can copy this data to the Excel. Okay. And this data is not available on the data, so I just try to copy. So I will hit select this, and then Control C. Go to my Excel. Control V. Okay. So looks like, yes, I can copy. Okay. So I'm going to go over this question. All right. So what is the question here? The question asks you, this is International Renal Federation estimates there are nearly 29,000 rhinoceroses live in the wild in Africa and Asia. A breakdown of the approximate number of rhinos of each species is reported in this table. Okay. Question A, construct a relative frequency table for the data. Question B, display relative frequency in a bar graph. Okay. So maybe we'll focus on question A and B using Excel. Okay. So I just copied the data. Question A, what construct a frequency table? Okay. Frequency table means relative frequency. Okay. So I'm going to create a new column here. Frequency, relative frequency. By definition, the relative frequency. I'm going to wrap the text. Okay. So by definition, relative frequency equal to the number, each number divided by the total number. Okay, so this is relative frequency for African black. Okay. So after you do the first calculation, put your mouse pointer on bottom right corner. Then until you see fill handle, click and drag down. Okay. So I need to modify the formula because I get this error. The reason is we should use absolute cell reference for the total. So this B8 is the same, is a fixed number for R. Okay, so I'm going to change this to absolute cell reference by press F4 if you are using PC. Okay. See, I modified the formula. The formula is B3 divided $B$8. After modification, you can then use the fill handle to click and drag down. So this time it works. Okay. So this is the answer for question A. Create a relative frequency table. Question B, display the relative frequency in a bar graph. Okay. To do that, you have to select non-adjacent data range. Okay. So first select this one and press and hold down Control, select this one. So by using Control key, you select non-adjacent data range at the same time. If you are Mac user, you use Command to select non-adjacent data range. After that, you click Insert. The question asks you to create a bar chart. So go to Recommended Chart. Maybe this is the bar chart. Okay, and you can select this one. Okay, so and adjust, maybe move this aside. Okay. And do some formatting for these charts. So for example, add a title. Okay, you can change the title by double click and then change the title. All right. So that is how do you analyze qualitative data, usually by create the relative frequency and then use the graph, pie chart, column chart, etc. Okay. So this is qualitative data. And the next session is about quantitative data. How do you describe quantitative data graphically? Okay. Quantitative data. So this is the session 4, quantitative data. The exercise is on page 16. So I go to page 16. Where is my page number? Sometimes I have trouble locating the page number. I want to go to page 3. Okay, it's here. Okay. So I'm going to go to page maybe I will do one question from page 17. Page 17. And question 1.20. Question 1.20. Okay. So this question 1.20. So what is this question about? Irrelevant speech effects in a psychological study of short-term memory. Just try to move this. Irrelevant speech effects refer to the degree to which the memorization process is impaired by irrelevant background speech. For example, trying to memorize a list of numbers while listening to a speech in an unfamiliar language. An analysis of irrelevant speech effects was carried out and published in Statistical Science of Technology. Subjects performed the memorization task under 2 conditions. 1, with irrelevant background speech, and 2, in silence. The difference in the error rates for the 2 conditions, called the relative difference in error rate, was computed for each subject. The RDER values for 71 subjects are listed at this table here. Okay. So there are 3 questions. So I'm going to time limit. I will just go to question A and question B. So question A, construct a relative frequency histogram for the data. Use class intervals with endpoint -45, -15, etc. Okay. B, from the histogram, estimate the proportion of subjects who had RDER values between 75 and 105. So this question gives you an example. How do you analyze quantitative data? See, the data given here are all numeric data. Okay, just by looking at the data, we cannot get anything, okay? But by analyze by create a frequency histogram, we can see the pattern of the data. And we can also answer some questions. For example, how much percentage between 75 and 105? But first, we need to copy the data into Excel. Okay, so we need to go to the data file. Okay, my data file is, where is my data file? All right, I'll try to locate the data file. I'll go to my computer. Okay, I will go to Excel to open this one. Go to Excel and then go to File, Open. File, Open. I save data file in this computer. Let me see. This computer, then C drive. This computer. And then I'll go to local C. So Ryerson 042. Where is my data file? Exercise examples. All the data files, it is here. So this is all files. The file name is ISR. This is alphabetically ordered. ISR. ISR, this one here. Okay, so I'll click open. And then I will save this file in Excel file. The data file, originally it is a CST file. So I'm going to click File, Save As, this PC. And then I will save another location. Documents. Under Documents. Maybe same location, no, same folder, but different folder. C drive, Y442, then mine. So the name is, I will save in Excel file. Excel. Okay. And I will attach my name to avoid confusion from original data file. All right, so this is the data. Once you get this data, see, there are total 71 data. Okay, this the first row is the heading. Okay, so question A. What is the question A here? Construct. Maybe I will move this. Construct a relative frequency histogram for the data. Okay. Use class intervals with endpoint. Okay. So, oops, sorry for interruption. Relative frequency histogram. All right, I will do this in the next session. I have some situation with my doggy, so I will pause, oops, stop sharing, and